Welcome to our third video on ratios. In the last two videos, we learned how to identify a ratio, make a ratio, and simplify ratios. In those videos, we were focused only on part-part ratios. Today, we're going to talk about part-part ratios as well as part-whole ratios. Finally, we'll also learn how to compare masses, lengths, and volumes rather than just counts of different objects. Let's get started. So first, I'd like us to recap what we've already learned about ratios. Let's remember, the ratio of circles to triangles in this picture is 4:3 because there are 4 circles and 3 triangles. When we flip it around and ask for the ratio of triangles to circles, it's 3:4 because the numbers always have to follow the same order or pattern as the words. So we can see our answers there. Next, we know how to write the ratio when we have equal groups of numbers. So here we see 18 jars of jam and 12 jars of peanut butter, but we can also look at those as groups of 6. So the ratio of the number of bottles of jam to the number of bottles of peanut butter is 3:2 because there are 3 groups of 6 bottles of jam and there are 2 groups of 6 bottles of peanut butter. We also see this with simplifying. The ratio of 18 to 12 can be simplified by dividing by 6. 18 divided by 6 is 3, 12 divided by 6 is 2. So our ratio is 3:2. Now if we flip that around and ask for the ratio of peanut butter to jam, then our ratio is 2:3. Remember that in this problem, Yen really struggled because she was trying to compare groups, but those groups were not in fact equal. So on the right side, we see the white eggs, which have 8 eggs per tray. And on the left side, we see the brown eggs, which have 6 eggs per tray. So she wasn't able to simplify that easily because she couldn't just divide it into the number of trays. She had to actually focus on the number of eggs itself in order to make a correct ratio. Now, let's start our new journey, part-whole ratios. So in a part-whole ratio, instead of comparing some things we have to other things we have, we compare one quantity to the whole amount. So if I'm thinking of all my beautiful markers and I have so many green markers, I'm comparing the number of green markers to the total number of markers. In this case, it can be a little bit tricky because when we find the whole, we need to count that part again. Let me show you what I mean. All right, let's picture it. So here, the number of orange juice packs to the number of apple juice packs is 2 to 5. We can see those 2 packs of orange juice and the 5 packs of apple juice, each of the packs having the exact same number. So they're equal groups, okay? 2 cartons to 5 cartons is 2 to 5. The ratio of the number of apple juice packs to the number of orange juice packs, now I flipped it, is 5:2. Remember, the numbers always follow the same pattern as the words. Now we're going to try a part-whole ratio. In order to do that, we have to think not just about orange packs and apple packs, but how many juice packs are there all together? Well, let's add. There's 2 orange packs and 5 apple packs. 2 plus 5 is 7. So the ratio of the number of apple juice packs to the total number of juice packs is 5 to 7. Notice that 7 there representing the whole number, and 5 is just representing the number of apple packs. Let's try. We found the ratio of circles to triangles, 4:3. We found the ratio of triangles to circles, 3:4. Now, what's the ratio of triangles to all shapes? Well, first we need to figure out how many shapes there are altogether. If there are 4 circles plus 3 triangles, 4 plus 3 gives us 7. So if we're making the ratio of triangles, 3, to all shapes, 7, we're going to have the ratio 3:7. Do you see how this is a little bit different from making a part-part ratio, where we're counting the circles and counting the triangles? This time we actually take a step back and look at all of the shapes together. So here are your answers here, which you can see. Now let's try a few examples together. All of these are vegetables, but we need to find the ratio of vegetables to potatoes. So we're looking at the whole thing as related to the part, okay? So you're going to need to count all the vegetables, and after that, you can count just the potatoes. There are 8 vegetables in total. There are 3 potatoes. So the ratio of vegetables to potatoes is 8:3. This is a part-whole ratio because one of our numbers tells about the whole amount. Now, let's look at another example. We're looking at the ratio of stationery to erasers, okay? In this case, pens, pencils, and erasers are all part of our materials or stationery, okay? So we're looking at the whole in comparison with the part. Let's count the whole bit. There are 7 total items. Let's count just the part, the erasers. There are 1, 2, 3, 4 erasers. So the ratio of stationery to erasers is 7:4. Now we're going to go back to part-part ratios, but try something a little bit new, okay? In the past with part-part ratios, we've been making a count of one object and a count of another object and comparing those two counts. Remember that a ratio is always a comparison between two numbers. In this case, instead of just counting how many something is, we're actually going to be counting how long or how much we have of something in comparison to how much we have of something else. So let's use measurement and create some new ratios. All right. In this picture, we can see a pineapple and a watermelon being weighed for their mass. To compare the two masses, they have to be in the same unit. Let's look at these scales. Both of the scales are written in kg, or kilograms, so they're in the same units. The pineapple weighs 2 kilograms, and the watermelon weighs 3 kilograms. 2 kilograms to 3 kilograms gives us a ratio of 2:3. Notice, the ratio is not 2 kg to 3 kg. In ratios, we just use the numbers. For the ratio to be valid, they have to have the same units anyway, so we don't need to repeat the units. The ratio of the mass of the pineapple to the mass of the watermelon is 2:3. All right. Let's try to go a bit deeper into this. We know the ratio of the mass of the pineapple to the mass of the watermelon is 2:3 because one weighed 2 kilograms and the other weighed 3. The ratio of the mass of the watermelon to the mass of the pineapple, see how we flipped the order, is 3:2. The ratio of the mass of the watermelon to the total mass of fruits is. Now we are going with a part-whole ratio. So we know the watermelon weighs 3 kilograms. To find the total mass of all fruits, we need to add up the two masses we found before. 2 plus 3 is 5. So we can say the ratio of the mass of the watermelon to all of the fruits gives us 3:5. Let's try a new element with length. First, we worked with mass, and now we're working with a different measurement, length. So here the textbook uses the terms length and breadth. You're probably more familiar with length and width, but breadth and width can mean the exact same thing for these purposes. We see each square is equal to 1 unit. If we look at the length horizontally, we can count 5 units, 1, 2, 3, 4, 5, from left to right. So the length is 5 units long. The breadth or width can be counted vertically, 1, 2, 3, 4. So we see 4 units from top to bottom. The ratio is going to compare 5 units and 4 units. But remember, when we write a ratio, we only write the numbers. So the ratio of the length to the breadth of the rectangle is 5:4. The ratio of the breadth to the length of the rectangle is 4:5. Same thing. As we follow the words, we follow the numbers. Now, I want you to help me try. We're going to work on this with volume. I want you to notice the water measured in each graduated cylinder. We are given some markings, 500 milliliters, and 1 liter. So we know that each of the marks is counting by 100 milliliters. Okay? This is the same concept we use when we use a ruler to measure. I want you to look and see that the volume in container A is 400 milliliters, and the volume in container B is 600 milliliters. So the ratio would be 400 to 600. Remember, we removed those milliliters, and we can definitely simplify that. So think about what is our greatest common factor that we can divide by. Hint, we should definitely start by dividing each of them by at least 100 because we were counting by hundreds. So those are equal groups. Then we have a ratio of 4 to 6. Think, Can you divide that any further to make it simpler? Yes. Next, find the opposite. If we look at the ratio of container B to container A, and finally, we can look at the part-whole ratio. What is the ratio of the volume of water in container B to the total volume of water? This is pretty tricky. We need to add up the total volume of water. So we need to add up the milliliters in each container. Finally, we'll compare the two numbers and simplify by dividing as much as we can until we can't divide anymore. But remember, it's only valid when we divide by the same factor on each side of the ratio, just like when we were simplifying fractions. Let's look at just a couple more examples. The ratio of total balls to basketballs. Well, there's 3 basketballs and 6 total balls. So the ratio would be 6 to 3 or 2 to 1. Do not forget to simplify. Next, the ratio of insects to spiders. So all of these are insects and we only have 2 spiders there. So we can find that the ratio is 9 to 2. In this case, we do not need to simplify because 9 is not a multiple of 2. There's no factor by which we can divide both of them and get a simpler number. Today, I want you to remember that we recapped our introduction to ratios. We looked at how we created part-part ratios and we remembered how to simplify. Next, we looked at part-whole ratios, where we compare a quantity with a total quantity. We have to zoom out to see everything that's there. Finally, we use part-part ratios and part-whole ratios to compare lengths, masses, and volumes. Thanks for enjoying this class. See you next time.